So today we have a 2008 Honda CR-V. It's here for a routine service and an inspection. Customer just bought the vehicle and he was told that the AC doesn't work, so he wants me to check it out to see why the AC doesn't work. I've got the AC on right now and I hear the radiator cooling fan running, but the AC compressor is not running. That's the AC compressor down below. I'll try to focus in on it. So you can see the compressor is not turning below the alternator there. So it could be low on refrigerant. There could be an electrical issue. So we're going to scan it and see if there's any fault codes. So I've set up and done a network scan here, and as you can see that there are no fault codes in the engine, but we have tire pressure sensor codes. It's got winter tires on it, but the TPMS sensors may be malfunctioning, if this even has tire pressure sensors. No signal from left impact sensor. Well, there's no airbag light on. Abnormal battery voltage, abnormal battery voltage, abnormal battery voltage. And that's the end of the code scan. So all the maintenance monitors have run and passed, so it hasn't had the battery disconnected recently. We're going to clear out all of these codes, but then we're going to look at some data in the engine control computer and see if we can see AC pressures. I got to do this with key on, engine off. So I've got the key on, engine off now. We're going to do a network code clear and listen to my compressor running in the background. This might take a few seconds, so we'll pick up when it gets to the end. So it's finished this network code clear, 12 controllers, all codes cleared, okay. So now we're going to go into engine, because I'm pretty sure it's the engine computer that controls the AC. It's probably under accessory data. AC clutch off, AC switch off. I have it not running now, so that would make sense. So we're going to watch AC switch, AC clutch. I'm looking for AC pressures. AC pressure in PSI, 71. Well, it's not empty. The static pressure in an AC system is pretty much equivalent to degrees Fahrenheit. And it's roughly 70 degrees in the shop here, so that would make sense, about 71.7 psi static pressure. So the system is not empty, so we don't need to, well, unless everything else points to the fact that this AC pressure switch is lying. So we're going to start it up now and watch what these sensors say. So here is the schematic for this AC system, or at least a portion of it. You can see the AC compressor clutch relay right here is ground side controlled by the PCM. Now PCM data was showing that it wants it on. There's a 7.5 amp fuse feeding pin 1 of the relay, and pin 2 of the relay goes off to, I imagine, the actual AC compressor. That's probably the second diagram here. Let's have a look at this one. Nope, let's go back. This is automatic AC, so I got to go to page 60-6. So here it comes in and it goes into the AC compressor through a joint connector and ground. So we're going to go back to this previous diagram and have a look at this 7.5 amp fuse in the underhood fuse relay center and check continuity through that relay. So this is the fuse panel under the hood, and fuse 20, which according to this is 7.5, is MG clutch, which stands for magnetic clutch, I would imagine. That's that 7.5 amp fuse right here. And as you can see, it lights a test light on both sides, so that fuse is good. So we have to figure out which one of these relays is the AC clutch relay. So it looks to me, according to this symbol, that it would be, that's radiator cooling fan. There's a snowflake here, so that could be it. Now we're going to have to find out, because it can't quite show. I'm thinking it's this one here with the snowflake, but then there's a snowflake here too, so we'll get a better picture of this relay center. So looking back at the schematic here for this relay, if I go to this photo view, it should show me a picture of the underhood fuse box. Hopefully it'll show me the layout. Well, that's pleasant. Thanks, Honda. I knew that was the... I want to know what fuse is which. I gotta find a picture of the relay. So did a keyword search for the air conditioning compressor clutch relay and component location. Let's see if we can find that. Oh, there we go. So it was that one with the snowflake on it. So let's have a look at doing some tests at that relay. So here's a bit of a snafu. Honda has proprietary numbers on the schematic. I'll show you on the diagram here. Pins 3 and 4 don't correspond with the relay pins. That's actually pins 2 and 1. And pin 1 over here is really pin 3, and pin 2 over here is really pin 5. Here's the layout of the relay on the bottom. This is the bottom view of the relay. So this is pin 1 and 2, and that's the control side of the relay. 3 is the same as 30, that's the high current power in, and 5 is the high current power out to the relay clutch. So I've renumbered them on the schematic here to correspond with the actual numbers on the bottom of the relay. That's going to screw somebody up if they're looking at the relay numbers because they don't match the schematic. Let's have a look at the relay. So I don't know if you're going to be able to see this on this relay. Come on, focus. So you can see the 3 and 5 on the large terminals. So this is 3 and it has power. And it gets sent out 5 when the relay turns on. This is pin 2, which is the control side of the relay, and it's ground side controlled by this. I know the relay is working because when I plug it in I can hear it click. So the control side of the relay is working. It's sending power in on pin 30 and power out pin 87, or power in on pin 3 and out pin 5. So we're going to check continuity across these two pins. And if we have no continuity, that means we have an open in the control circuit. And the way you're going to do that is put a test light across these two pins. Well, the compressor should be running because we have continuity through there. Well, let's try that again. Let's plug this in. I don't hear the compressor clutch engaging, so maybe there's excessive air gap on it, and that's why the magnetic clutch is not engaging. Let's have a look at the compressor again. Well, I can see the front of the compressor is not turning, so there's a definite problem. So we're going to have to take some guards off underneath the car and have a look at that. So if you look through the left front wheel well opening after you move the plastic guard here, you can see the compressor is not turning. It's not seized. I'm pushing on the compressor up plate, and usually if there's an excessive air gap, it'll engage when you press on it. So we're going to have to find the connector and see if we've got power down here. So remove the push pins and you can get at this compressor here. Now I see there's a thermal fuse on here. That's usually a thermal fuse. So it didn't show that in the schematic. I'm gonna have to see how this thing's wired. I'm gonna get a picture of this AC compressor clutch circuit. So here's the other half of the circuit, and this comes from the compressor clutch relay. Purple wire goes through a joint connector, turns to a red-white wire, and goes directly to the AC compressor clutch coil. Now I showed continuity through there with the test light. Now mind you, my test light only draws about 150 milliamps, so maybe I should have used a heavier load, because this thermal protector is in parallel in the circuit. It's not directly in line like some early Hondas. Well, let's see if we got power down there. So I'm going to check for power right at this pin 3 on this red-white wire coming into the AC compressor with a test light with the compressor plugged in. So I have a back probing pin into that red wire, and if I can get my test light on here, you can see that there's power at that red wire. So the compressor clutch is failed. Now why did it light the test light when I put it across there? My assumption is my test light only takes about 150 milliamps to light up. So let's try it with a heavier load. Well, I have continuity through the coil. I put a headlight in there which takes about 2.5 to 3 amps to power up. And I put it in series and it turns on the headlight. So that means there's continuity through that coil, but it's magnetically not pulling in for whatever reason, which is really strange. So I've got the relay bypassed with a jumper wire, and you can see there's magnetism on the front pulley. It's holding a screwdriver up there, yet it magnetically doesn't pull into the spinning clutch, and the air gap doesn't look excessive. That's really strange. I've never seen other than with a wide air gap, but normally you push on it and it would engage. Like there's magnetism there holding that pulley on, as you can see, or holding that screwdriver on the pulley. So the clutch is working, but it's not engaging. Magnetically it's working. So I've come to the conclusion that this thing needs an AC compressor clutch coil, which is probably only serviced by replacing the entire compressor, or at least the compressor has to come off to do that. So we're probably going to look at a previously enjoyed AC compressor assembly. That's grounded all the time, and as you could see in the previous clip, there was magnetism there, but it's not pulling the compressor clutch drive plate into place, and I don't know why. So we'll look at sourcing a used AC compressor and discuss that with the customer. And if there's a follow-up video, I'll post replacing the AC compressor and recharging the system.